In this video lesson, we are going to talk about graphing cubic functions. Now, what I would like to do before we actually begin here is to review the parent function. So remember, the parent function is y equals x cubed. Just like the quadratic function, the x values are -2, -1, 0, 1, and 2, but the y values look a little bit different. Remember, if you can't remember what the y values are, you can simply cube each one of these numbers. When you do, you will figure out that the y values are -8, -1, 0, 1, and 8. Now, the graph looks like this. It has kind of two branches here. It's asymmetric in nature. And then some key characteristics of this that we want to talk about are our x-intercepts, the y-intercept, and the end behavior. So this particular function, the parent function, is pretty basic. So the x-intercept and the y-intercept happen to be the same at 0, 0. End behavior, remember, is what's going on at the very end of the graph. So as x approaches positive infinity, so that's on this side of the graph, y approaches positive infinity because on the right side the graph is getting larger. And as x approaches negative infinity down here, y approaches negative infinity because the graph is getting smaller on the left. So hopefully this is a nice refresher from Unit 1, and we can go ahead and take a look at the actual graphs today. So the first function that we are going to graph is y equals the quantity x minus 5 cubed minus 2. Now you can see here that I already made note of the transformations because this function is in transformation form. We can easily see the transformations from this form. Once we've listed the transformations, we can apply them just like we did in Unit 1. So for our x values, we are going to move them to the right 5. So we're going to add 5 to all of our original or parent function x values. And for the y values, we're going to subtract 2. Once we have gotten this table of values, we can go ahead and plot the points and connect them like so. Just as the directions state, we do need to go ahead and find these characteristics here. Something new on this problem that we have not seen before is that we don't know what the exact x-intercept is. It's somewhere over here. So we are going to, for now, simply state that the x-intercept is between x equals 6 and 7. We'll learn later on how to actually find those exact values, but for now, that's what we're going to state. The y-intercept is not a value that we can see, but we can actually calculate this without too much difficulty. Remember, a y-intercept, we want to plug 0 in for x and then simplify. When we have done that, we get 0, -127. Now remember, graphing is always a non-calculator problem. I know this math can be tricky, but I promise you, you have the ability to do it, so believe in yourself. Then we have the end behavior here. So here is our end behavior. Again, as x approaches positive infinity is the right side of the graph. That graph is pointing up, so we say that y approaches positive infinity. As x approaches negative infinity, down here, y approaches negative infinity because it is pointing down just like the parent function is. So for problem number 2, I would like you to pause the video and try this. Okay, I want to see, can you figure this out without my prompting? Once you think you've gotten it, go ahead and hit play and see how you did. So go ahead and hit pause right now. Okay, so let's see how you did. The first thing that you need to do is you need to list out your transformations. So for this particular function, we're going to have an x-axis reflection, a vertical stretch by 2, and up 3. After we've done that, we're going to need to make a table here, x-axis reflection, vertical stretch, and up 3 all affect the y value. So we need to remember the order that we do these in. We are going to multiply by -2 first, and then we are going to add 3. Remember, the values on the outside of the parentheses we do in order of operations order. So we multiply, and then we add. So the x values are going to stay exactly the same. No change here, no transformations that are going to affect them. But for the y values, we remember need to multiply by -2, and then add 3. When you do that, you get the y values that are listed. I'm sure some of you are going, well, how do I graph this? My grid is only 10 by 10. And we have a couple of values, for example, this -219 and +2, -13 that don't fit. We are simply just going to graph the values that do fit. Now you want to keep your table of values the same, but you simply graph the values that fit. When you do graph, you should get a cubic graph that looks like this. Remember, this has been reflected over the x-axis, so the side pointing up is going to be on the left this time instead of on the right. After we've graphed, we want to list our characteristics. This is a similar problem to the previous example where we do not know an exact x-intercept. It's somewhere in this neighborhood right here. So we're going to state that the x-intercept is between x equals 1 and 2. Don't forget the x equals. It's really important. Don't just say between 1 and 2. I don't know, or your teacher doesn't know what you're talking about there. The y-intercept, this one is actually on our table, so that's nice, 0, 3, and then we get our end behavior. Remember, we want to know what's going on the right side of the graph and on the left side of the graph. So as x gets really big on this side of the graph is pointing down. That signifies that y is approaching negative infinity. On the right side of the graph up here, as x approaches negative infinity, as on the left side of the graph, as x approaches negative infinity, y is going to approach positive infinity. So these two examples were both in what I like to call transformed form. We can see the transformations. Examples 3 and 4, we're going to need a different strategy. So let's see what these are going to look like. So example number 3 here, if I can get it to show up, is not in transformed form. This is what's called standard form, where we have all of our parentheses multiplied out. We are in what's called descending order, where the degrees on the variables here are from smallest to largest. So we have x cubed, x squared, x, and then a constant. For this particular problem, we actually need to factor it. Now remember, to factor 4 terms, we need to factor by grouping. So in order to factor by grouping, we need to put the first 2 terms and the second 2 terms in parentheses. Notice that that minus sign here ends up in the parentheses. That's really important. So now that you've grouped this, you need to ask yourself, what is the GCF of the first term or first set of parentheses, and what is the GCF of the second set of parentheses? The GCF of the first parentheses is x squared. So when you factor out that x squared, you are left with the quantity x plus 2. Now the second set of parentheses, it doesn't look like there is a GCF, but because we have a leading coefficient that's negative, we need to factor out a -1 from this set of parentheses. So when you do that, you end up factoring out the x plus 2. Now this looks kind of funny here. What do I do next? Well, both of these terms have the x plus 2 in common. So we need to factor out the x plus 2. And our leftovers are going to be our 2 GCFs, which is x squared minus 1. Now, this particular problem is not done. We have the pattern difference of squares here, so we can go one step further and get a final answer of x plus 2 times x plus 1 and x minus 1. And don't forget your y equals, because this is still an equation. Now, in order to graph this, we're not going to make a table of values. We need to use the x and the y intercepts in order to be able to sketch this graph. I like to call this an accurate sketch, because we're going to get our x-intercepts and our y-intercepts and then sketch in from there. So our x-intercepts, once you're in factored form, you can use the zero product property, where you split this up and set each set of parentheses equal to 0. When you do that, you get x-intercepts at -2, 0, -1, 0, and +1, 0. In order to find the y-intercept, I recommend going back to the original problem. Remember, in order to find the y-intercept, we want to plug 0 in for what we don't want. In this case, for x. When we plug in 0 for all these terms, we're simply left with the -2. So our y-intercept is 0, -2. Once you go ahead and plot all of those points, you need to connect them, and knowing how the end behavior is affected by the leading coefficient can be very helpful here. Okay, remember, when our leading coefficient is positive, the right side end behavior is positive. When the leading coefficient is negative, the right side end behavior is negative. So what's this leading coefficient? Look all the way in the front. there is a hidden positive 1, which means that the right side end behavior needs to be positive. So that allows us to connect the graph like this. Notice the right side of my graph is pointing up, and then I pass through all of my points and then have arrows on both ends. A lot of students ask, well, how high or how steep? That's why I call this an accurate sketch. As long as you're going through the points you need to go through and your end behavior is correct, you're good to go. The other points are not necessarily as important in this particular form. Now our end behavior, we've already talked about this. The right side end behavior is that positive infinity, okay? And then on the left, as x approaches negative infinity, this particular graph is pointing down. So we know that that end behavior is approaching negative infinity. Now, since this form is new, I am going to walk you through this next problem here. You're going to notice that this next problem has a leading coefficient that's negative. I don't like factoring when the leading coefficient is negative, so the very first thing that I like to do is I like to factor out that negative sign. So what I would like you to do here is I would like you to go ahead and pause the video, and I would like you to try to factor this. Now make sure that you check your factored form before going on to graphing, but go ahead, pause the video, and see if you can factor this, okay? So go ahead and pause the video now. Okay, let's see how you did. So here we are after we've grouped. Here we are after we've pulled out the first GCF and the second GCF. Again, we have the x plus 2 in common, and you're left with the x squared minus 4. X squared minus 4 can go one step further, so when you fully factor this, you get the form here. Negative times the quantity x plus 2 times the quantity x plus 2 times the quantity x minus 2. So once again, we need to get our characteristics before we can graph. So for this particular problem, we only have two x-intercepts. We have negative 2, 0. That comes from both of these, right? These both will give you x equals negative 2. And then the x equals positive 2, or the 2, 0 comes from here. Now, I like to note that the the negative 2, 0 has a multiplicity of 2. We'll talk more about multiplicity further along in this unit, but I do want to point this out because it's going to affect the way we graph this. Y-intercept, we're going to get the same exact way as previous. We're going to plug 0 in for x, and we get 0, 8. Now, with 3 points, this looks like it's going to create a parabola, right? At first glance, there we go. Loop it through, we get a parabola, but we are graphing a cubic. Okay, so this is where the idea of the multiplicity comes into play. This times 2. At x equals negative 2, because it's a multiplicity of 2, we are going to bounce off of that point as opposed to passing through the other one. The last thing we need to look at is our right side end behavior. This leading coefficient is negative. So the right side end behavior is negative, so we're going to be coming in from the bottom. So knowing that, we need to come in from the bottom, down here, and that we need to pass through this point, we're going to end up with a graph that looks like that. Again, the right side end behavior is negative, pass through, and bounce. Don't forget your arrows. Now for the end behavior, we have talked about already the right side. Leading coefficient is negative. We have that negative right side end behavior. And on the left, as x approaches negative infinity, this graph is pointing up. So y is going to approach positive infinity. I hope after watching this video, you feel comfortable graphing cubics, both in transformation form and standard form. Please feel free to reach out to your teacher or head to the mark if you are having trouble with this. Thanks for watching.